So basically a factorial is basically like a mathematical notation in combinatorics that represents like the number of ways to like arrange some like objects in a line. So maybe this will make more sense. So if you say like n factorial, right? So let's first talk about factorials. Uh so n factorial, like you use this exclamation point here to like represent a factorial. So you would read this like n exclamation point. Like it's not like in English class where it's like, you're excited to see the variable n. It means like n factorial. Like this exclamation mark in math is read as factorial. Um like n factorial, this by definition, a factorial is going to be equal to the product of all the positive integers less than or equal to n. So n factorial would be like n times n minus 1 times n minus 2 times like all of the numbers all the way down to like 3 times 2 times 1. So like for example, like 4 factorial would equal 4 times 3 times 2 times 1. Like 10 factorial would equal, it would equal 10 times 9 times 8 times 7 times all the way to like 3 times 2 times 1. So like it's essentially just the product of all the positive integers less than or equal to that number. And like the reason factorials are important is because like one of like the most like standard and classic examples in combinatorics is like, let's say you have 5 objects, like, or let's say you have 5 people and you want to know like how many ways are there for these 5 people to stand in a line or something. So if you were to call these people like A, B, C, D, E, and you wanted to find like how many ways are there to arrange these people in a line, then basically what you would do is like you have like 5 ways to choose who stands first in the line, right? Like the first person in the line can be A, B, C, D, or E. So there are 5 choices. Let's say you chose like person like C or something, right? Then that means you can't choose person C again. So in this second spot now, you have 4 choices to choose which person stands second in line. So you would do times 4. And let's say you choose like person B or something. Then now you would have like 3 choices for who stands in the third spot. So let's say you choose like E or something. So times 3. And then let's say there are 2 ways left to choose like who stands in the 4th position. Let's say you choose like A or something. So times 2. And then like there's only 1 way to choose like who stands in the last position. So like person D times 1. So then you would just have 5 times 4 times 3 times 2 times 1. And this is just equal to 5 factorial. And if you were to calculate this, this should just be 120. And this is why like factorials are important because they appear like very often in like many different combinatorics problems. And this is probably like one of the most like standard and like common problems that you'll see in combinatorics.